All right, 7.3, last example. Let's first look at an example that we could have seen in 7.1. So 43 and 47 had us doing some different stuff. So it's going to pop up in this last example. So write this down or just watch. I'm going to work this expression out by evaluating the innermost parentheses first. So first I want to figure out where negative 10 pi over 9 is within the xy plane. So I'm going to rewrite 10 pi over 9 with the pi outside a set of parentheses, like so. And then I'm going to rewrite it as that negative 10 over 9 is negative 1 minus 1/9, right? And just to be sure, 10 divided by 9 looks like that, right? So I can rewrite negative 10 over 9 as negative 1 minus or plus negative 1/9. So negative 1 minus 1/9. And then I can put the pi back through, and that's what it looks like. So if I want to evaluate this, where the heck does negative 10 pi over 9 sit within the unit circle? Well, I'm going to take off from the positive x-axis, and it looks like I'm going to spin negative pi. So there's my negative pi, and then I need to spin negative pi over 9 more. So that's not too far in, not even that far in actually, but at this point it doesn't matter. I know it sits in quadrant 2, so that's what I need to see. So this is a reference angle of pi over 9, right? Because this to the positive x-axis, or I'm sorry, the negative x-axis, was negative pi, which is coterminal with pi. Actually, let's just say that. Let's just say this is where pi sits if I was cruising around this guy regular. Whoops. You know, from 0 to 2 pi. So this is a pi over 9 reference angle. So I have no idea what the x, y, r values are, but it doesn't matter because the ultimate question is what's the angle, right? So this is going to give me, and I think I did this with you in the notes when we were in a Zoom. I said this is going to equal some ratio, and it doesn't matter what it is. You're now going to take the inverse cosine of this ratio. So inverse cosine is going to give you an angle. And if you want to do the rewrite, you can do that. We could say inverse cosine of some ratio would also be the same as cosine of theta equals some ratio. So what's that angle? Well, this angle is sitting right here. It's pi over 9 radians shy of pi, right? So this is pi minus that reference angle. So what is that, 8 pi over 9? And then where else? Oh, actually, and then that's it because this is from 7.1. So this is where you can only use the restricted domain because we're given this as something to evaluate. When we solve our equations, they're telling us to use only positive angles and give as many as you can, okay? So that's how that worked in 7.1. And that's how this is going to work in 7.3. But in 7.3, we're using the whole circle, right? So now you might want to write this down. Again, though, you could just watch. It's a video. You could pause, rewind. It's not an ed puzzle, whatever you want. So same directions as the ones that we've already done. But I did add that it is going to be easier if you put your angles in degrees. I didn't do that in that last one. In this one up here, I left it in radians. It's up to you. You could leave it in radians, though this time the radians are in decimal value, so it might get a little funky. I really suggest you do the degree thing. So here I go. I'm solving, so I'm going to apply inverse sine. So I got to get theta by itself. So I'm applying inverse sine. I'm not using a restriction. They want me to give only positive angles. Okay, so we're looking at theta sitting by itself is equal to this. Okay, so I'm going to go to my calculator and I'm going to ask it, what is the inverse sine? What angle would I be taking the sine of and get negative 2/10? And I got to be in radians. And the giveaway that I got to be in radians is they're telling you you're in radians. They're telling you to look for angles in radians, and that has to be a ratio from a radian angle, an angle measured in radians. So going into my Desmos, I'm going to click above the buttons 7 and 8. I'm going to slide it over so I'm in radians. And then I go to function and I do inverse sine. And what was it? 2/10. So go back to the main buttons. And I have 2013. So I'm going to turn this decimal value into a degree measure. It's still going to be a decimal value. Maybe I better write it down. So 2014. So my calculator just gave a decimal value of 0.2014. So now I'm going to multiply, oh gosh, sorry. I'm going to multiply my decimal value by 180 over pi, because that's the ratio we use when we do the conversion to degrees. So 180 over pi. And I get 1154. So theta is equal to 11.54 degrees. Okay, so I am now going to answer this question now that I know what the angle is. Theta is 1154, but it's going to happen twice. And it's positive, so it's going to happen right here. That's 1154. And then its sine is also positive in quadrant 2. So that's going to be 1154 degrees shy of 180, right? 0 to 180. So subtract 1154 from 180, and you get 168.46. $168.46. Now, since if you want to look in the back of the book, since that's what I'm giving you guys are the odds, because I want you to check your answers and then I'll work them out with you if you're not getting those answers, you need to turn this back into radian measure, okay? So I'm going to multiply both of these by pi over 180. Okay, so scooch this down. And that first one would already give us what we had. This takes us back to this value, right? 2014. I just wanted to see what it was in degrees so I could figure out where the heck else I'm supposed to go. And then this one is going to be 168.46 times pi over 180. And I get 294. So final answer in set notation. And I forget, sorry, but I forget how many decimal values. I know they changed it when they changed the edition of this book. I think 4 decimal places is always the safest. But my 294, why did I do that? I guess I could do 02 if I'm saying it's safe. When in doubt, go 4 decimal places. Better to be over with it than under. All right, so that is it. So you could try these three. It's not very many. Um, just remember where they're positive and where they're negative, and putting these into degree mode will help you with figuring this stuff out. So you do need your calculator. All right.